So Vx squared plus Vy squared. So you will now have your magnitude for velocity. Okay, and to compute for the angle of inclination, no, with respect to x-axis, so katawan, no, so tangent function is opposite, which is si Vy over adjacent niya nga si Vx. And recall, from respect to distance or displacement, it is dx over dt, and Vy is your dy over dt. So substituting those values, no, for dx, Vy and Vx, you'll have here dy over dt and dx over dt. So, reciprocal, no, property. So, mag-cancel out si dt, leaving us with the equation tangent theta with respect to x-axis is equal to dy over dt. So, what does this indicate ba? So, what does this mean? So, it only indicates, class, that your velocity is always tangent to the curved path of motion. No? So velocity is always tangent to the curved path of motion. Okay, since first degree man na siya, no? So meaning that is just a straight line. And by definition, di ba, tangent to a circle or tangent to a path, nag-meet lang sila or they are connected at a certain point, no, or at one point of the circle. So meaning your velocity class, no, at any given point in your projectile motion or in your curvilinear motion, it is always tangent, no? So, let's say, for example, at this point, ina na ang itsura sa imong velocity, and at this point, tangent. Okay? So, that is for velocity, no? So, how about the rectangular component of acceleration? So, if we consider this graph, no? So, si point A and si point B, di ba, you'll have this graph of your velocity, no, for point A and point B, since we know that velocity is tangent to the curved path of motion. So meaning at point A, your velocity is acting that way or in this manner, and for point B, your velocity is acting in this manner. So if ato nang i-draw ang ihang force polygon, you'll have this diagram, no? So for VA or velocity of at point A and your velocity at point B, no? So we are talking about acceleration. So asa man si acceleration ani? Ngano puros man ni siya velocity ato ang gakakita. So take note that diba acceleration is the rate is your rate of change of velocity, no? So meaning from this point to this point, that is your change in velocity, no? So your that is your change in velocity, and it only refers to your acceleration, since acceleration by definition is the rate of change of velocity or dv over dt, right? So if ato na siyang i-resolve into x and y component, you'll have this components, no, of your change in velocity in y component and change in velocity in x component. Okay? So meaning, if this line is our rate of change of velocity with respect to time, so that is only our acceleration, no, with respect to time. So this is acceleration. So meaning, ang atong acceleration, no, from point A to point B is in this manner. So this is acceleration, no, and our AX and AY, no, kani sila. Okay? Now, we have this another triangle, no? And if ato na siyang kuhaan ang angle, no, to determine the angle of inclination of your acceleration, So same lang gihapon nga function o tangent function. So by trigonometry, tangent angle theta with respect to x would be equal to ay over adjacent niya, no? Sa imong angle of reference is si ax. And by definition or by relationship no of your acceleration and displacement, recall na from our previous discussion that acceleration is the second derivative of displacement. Diba? So we have talked about that during our fundamental concept and principles no of dynamics. So your acceleration is the second derivative of displacement, in which in this case we've we have set displacement as x and y component no, di ba? Mo man ni siya. Your ganina ato ang isolve. Now, relating to this, you have d squared x over, sorry, y ang sa taas no. So d squared y over dt squared over d squared x over dt squared no. So mag-cancel out lang yapon si dt squared, leaving us with this equation na for the inclination of acceleration, d squared x over d squared y over d squared x. Okay? So what does this signify? It only means, class, that your acceleration is not tangent to the curved path of motion. No? Kay naka-second degree man siya. So wala na siya or dili na siya straight line. Kaya ang graph sa to ang second degree is naka-curve na siya, class. No? In fact, that is a parabola na graph. No? So dili na siya straight line. Therefore, your acceleration is not tangent to the curved path of motion, no? Excuse me. Okay. Sige. So, those are the concept no or principles no of general curvilinear translation. So another application or an application of curvilinear motion is this famous topic on physics no, projectile motion. So I know you have siya nga encounter before no sa physics. Sige, ato lang i-recap no ang inihang knowledge about projectile motion. So, the same assumptions no or considerations sa ato ang free falling body, no, air resistance is neglected. So, nga naman, di ba, we have talked about that already. And since we are still in kinematics of dynamics no or napat sa kinematics nga branch of dynamics, so dili pa nato i-consider ang factors or other forces no or external forces that may cause our object or our material to accelerate no. So meaning when dealing projectile motion, class no, we will just going to resolve the curvilinear motion of the path into rectilinear motion. So may pasabot ani no. So at any given point in your projectile motion, class, ato na siyang i-resolve into x and y component, no? So kuhaan na to na siya og x and y component. So if kuhaan na to na siya og x and y component, if atong i-consider ang x component na lang, meaning ano na lang siya, no? On horizontal motion na lang ang iyahang consideration. So ma-apply din nato ato ang fundamental concept and equations no for rectilinear motion with a constant acceleration. And also, if ato i-consider ang iyahang y component, or if kuhaan nato siya og y component, meaning it is acting on y-axis. No, therefore, that is, or the motion, or the nature of the motion of your projectile motion at any given point on the trajectory would be a vertical motion na lang, no? Or ma-apply na nato to ato ang discussion on free falling bodies, diba? That is why, class, that you have here the equations for projectile motion, no? So x and y component. So you just have to understand the assumptions no or considerations no when dealing projectile motion. So for x component, your acceleration on x component is equal to 0. So anong nag-0 man na siya? Again, di ba we are neglecting air resistance and other factor that may cause the object to accelerate. So meaning your acceleration on X component is always constant no, or constant lang na siya class and it is equal to zero. So laing factor no nga pa-cause sa ato ang object or sa particle to accelerate. So meaning zero lang ang iyang acceleration class. And then for your velocity on X component, you have this consideration na Vix is equal to Vi cosine theta. So, asa mo na siya gikan? So, earlier, no, we have discussed or we have talked about the rectangular component of velocity. So, if kaon mo ang x component sa imong velocity, so of course, you just have to take the cosine function no, of this relationship. So, cosine angle theta with respect to x is equal to adjacent nga si Vx over si magnitude nga si V. And ang atong objective diba is si Vx. So to determine the x component of velocity, cross multiply, you'll have V cosine theta. Okay? So dara lang na siya gikan class ang kaning iyahang assumption no, on x component of projectile motion. No? Sige, so kindly take note of that. No? Kaya later magamit kayo na to na siya. Now, for y component, you have here acceleration on y component of your projectile motion is equal to negative gravity. So nga naman, di ba from free falling bodies na ito nga discussion, you have when your direction of your velocity is opposite your sa direction sa ito ang gravity, you'll have negative sign on convention. So meaning, if we have this trajectory or curvilinear motion, so for example, at this point, ato na siyang i-analyze. Kuhaan na to siya og x and y component. So x and y, so meaning, ihang y component, diba, is acting upward and our gravity is always acting downward, meaning you'll have negative sign convention for acceleration class. Okay? Now, for the velocity of your y component in projectile motion, so the same case with the x component, no? So, dire lang niya po na siya na-derive class from the rectangular component of velocity, no? So, Vy atong nakuhaon, so you'll have to take the sine function, no? So, dara lang siya. Now, let us solve this or let us derive no the equations for projectile motion. Asa man ni sila gikan? Sige. But first, we'll have to unsa man ato ang basis ani no. So notice that your acceleration no in x and component is equal to 0, meaning constant siya class no. So constant siya, and your acceleration in y component is negative g. So gravity is always constant, diba? So constant na siya unless otherwise stated, no? Kung na siya line value for gravity. But that is constant, meaning the acceleration no, on both axes, no, on x and y, kay constant na. So napasabot, pwede na ito ma-apply ang ato ang concept noon rectilinear motion with constant acceleration. So that would be our basis no sa ato ang derivation sa equation. So first, di ba we have three available equations for rectilinear translation with constant acceleration. So first, si Vf is equal to, or final velocity is equal to initial velocity plus 80. So, di ba ang ato ang approach no in solving projectile motion is ato siyang i-resolve into x and y component. So if kung ano to na siya og x and y component, this would be Vx is equal to Vix plus Axt. Okay? So ato lang siyang kuhaan og mga x components, no? So Vx now would be equal to Vix, no, or the x component of your initial velocity. So, di ba, we have this assumption no, or consideration. So, Vi is cosine theta plus Axt. So, recall that our assumption on x component of projectile motion is it is always equal to 0. So, meaning class, cancel out lang na siya, no? So, any number multiplied by zero, so mag-zero lang na siya, no? So, regardless of your value for t, so, mag-zero lang na siya, kaya multiplied by acceleration on x component man, which is zero. Okay? So, mo na rin siya ato ang resulting equation. So, mo ni siya inyong makita sa inyong formula, no, for projectile motion. For the y component, we have Vy is equal to Viy plus Ayt. So Vy is equal to Viy, di ba? We have this Vi sine theta plus Ay, di ba ito consideration on Ay is negative G. So, ako na lang siyang i-direct substitute. So, minus GT. Okay? So, this is now our first equation for y component. Nara siya class O. So, muna inyong makita sa for projectile equations, no? Or the first formula for x and y component is from the first equation of rectilinear translation with constant acceleration. Okay? So, for the second equation of rectilinear motion with constant acceleration, o sa ganito, di ba, we have s is equal to VIT plus 1 half AT squared. Sige. So, if kuhaan natin siya og x and y component, so we'll have Sx is equal to Vix t plus 1 half Ax t squared. Now, again, Ax, no? We have this Ax, no, equal to 0, so this will cancel out or it will be equal to 0 lang. So, meaning, the resulting equation would be Vi cosine theta. So, Vix, di ba, is Vi cosine theta times t, no? And since we are considering, no, the horizontal distance or the horizontal displacement of your projectile motion, meaning ato lang siyang i-denote as x, no? So, this is now our second equation for x component of your projectile motion. So, nara siya class O. Muna siya. Okay. Let me just add another slide para natay space, no? Sige. So, for the y component of your second equation of rectilinear motion with constant acceleration, so let us have this second equation. Ano to siya, y component, so Sy Viyt plus 1 half Ay, no? Ay t squared. Sige. So, we are computing the vertical distance, no? So, y, ato lang siya i-denote as y. Viy is Vi sine theta times t minus 1 half, so plus sorry, plus ang ato di bang ay is negative g, so ako na lang siyang i-direct let out sa ato ang equation, so minus 1 half gt squared. Okay? And mao na siya inyong makita sa inyong equation or formula. Okay? Now, for the last equation of rectilinear motion with constant acceleration, di ba, masagal ito, it is final velocity squared is equal to initial velocity squared plus 2as. So, if kuha na to siya x and y component, you'll have this as vx squared is equal to vix squared plus 2axsx. So, this will be x lang, no? Sa ito ang pag-denote earlier, remember? Sx na ito siyang i-denote as x na lang. So, anyway, regardless, mag-equal to 0 lang na siya class, no? Since it is multiplied by ax. And our assumption no, on acceleration on x component of your projectile motion, it is equal to 0. Therefore, the resulting unit or the resulting equation would be Vx squared is equal to Vix squared, and square root both side, mag-cancel. Therefore, Vx is Vi cosine theta kay Vix man ano. So, familiar, no? So, notice nga same lang siya sa ato ang na-derive na first equation, which is kani siya, oh, si Vx is equal to Vi cosine theta. Okay? That is why, makita ninyo nga equation or ang akong gi-provide nga equation, no, for projectile motion on x component is duha lang siya ka equation. Since your derived x component, no, of equation number 3, kay ni-confirm lang man siya sa ato ang na-derive sa first equation. So what does this mean, no? So na siya'y pahiwatig, na siya'y pasabot class. It only means that your final velocity is just equal to the x component of your initial velocity. Okay? So always remember that your final velocity is just equal to the initial your x component, no, of your initial velocity, no? X component of vi man daw. So initial velocity, x component. Okay? Now for the y component, we have here y, or Vy, no? Vy squared is equal to Viy squared plus 2as Aysy. Then Vy squared is equal to Vi sine theta plus 2, di ba, ay is negative g, so minus 2g, then sy, ato na siyang gi-denote as y, no? Nara siya class of. Ato siyang gi-denote as y since you are simply computing for the vertical displacement, no? So ato na lang siyang i-let as y para uniform ang ato ang representation sa atong equations, no? So to avoid confusion, dapat uniform, no, ang ato ang representation all throughout our equation. Okay? And this is now our resulting equation, no, for y component of projectile motion derived from the third equation of rectilinear translation with constant acceleration. Okay? So, mura po na siya yung makita din in class. Oh. Okay? So, I hope nasabtan if asa gikan ang mga equations or formula. So, I hope na na-clarify sa inyo, no? Kung sa to ang basis or sa to ang legal grounds regarding this, no? So, dili kay memorize lang mo sa formula or sa equation without knowing asa sila gikan, no? Or unsa tong basis o unsa ang ato ang considerations na sa formula. So, okay? Now, as you can see, you have here the last equation of for projectile motion, which is kani siya class, no? Y is equal to x tangent theta minus gx squared all over 2vi squared cosine squared theta. So, sa book ni Ferdinand Singer, ato ang main course of reading, I don't think na gihatag na niyang equation, no? So, the last time I checked, which is very dugay na class, no? So, wala ni niya gi-provide, no? But actually, this equation class is very powerful, no? So, magamit kayo na siya, especially sa board exam. So, magamit kayo na siya nga equation. So, timan nyo, gini siya. So, this equation is derived, no, from second equation of x and y components lang. So, this involves, or kani siya nga equation is para na siya sa mga problems or situations nga dili ihatag ang time, no? So, there are problems or there are cases nga dili katagaan og time. So, notice also that in the equation, wala tay data for time, no? So, wala siya nag-involve of time. So, asa man na siya nakuha, no? Sige. So, let us derive that equation. So, I have mentioned that, diba, it is, or ihang basis ang second equation, no, of our x and y component. So, diba, we have this x component of our projectile motion is x is equal to vi cosine theta t. So, you have to remember, or you have to know that your vi here should be equal to the vi here. Kaya same naman na sila og value class no, or same ra dapat na sila og magnitude. Kay gikuhaan lang man nato na siya og initial, I mean gikuhaan lang man nato siya og x and y component no. So meaning dapat equal na siya. So isa na siya sa tuang legal basis na or ato ang basis gyud. So meaning if your VI it should be equal to the y component na VI. So atong i-express ang x component as VI no. So VI is equal to x over excuse me cosine theta t. Ay sorry. And also class no, since ako na siyang gi-mention di ba, and also you have to consider that your time here they should be equal also kani siya class no. So from point A to point B di ba, same naman na siya og time, dapat same sila og time, nagikuan na to siya og x and y component. So ato ni siyang i-express no. So t therefore is equal to x over vi cosine theta. Okay? So natay expression sa time no as a function of range and initial velocity no and your angle of inclination. Then i-substitute na to na siya diri nga equation. So you'll have ako na lang siya i-direct. So minus 1/2 g e times time, which is again i-express na to siya as x theta no? So they are just equal, so we can simplify hello na pa ba mo class.
Napa, sir.
Yes, sir. Dapat.
Magpilit, sir, ba? Magpilit-pilit, sir.
So sige no, sorry kayo kay na nawala ang internet connection for a while. So let me just share my screen again. Okay, so I think okay na no. I hope okay na ang akong audio and ang slide. So again, balik lang taan no. So di ba sine theta over cosine theta is just your tangent theta no from trigonometric identities. So ato siyang i-simplify as x tangent theta kay ang mabili no sa first term is x times sine theta over cosine theta minus So sa sa numerator, no, sa ato ang second term, you'll have ako sa siyang i-move kay para mausara na ako og write ang equation. Oops. Sige. So, sa second term no, sa atong equation, ang mabilin is walay mag-cancel out. No? So, g x squared to vi squared cosine squared theta. No? So, simplify lang nato siya. And, mo na siya to ang derived equation. No? So, the relationship of your vertical distance and horizontal distance or displacement. Okay? Sige. So, to better illustrate and to understand further the concept of projectile motion, let us solve sample problems. We have here sample problem number 1, situation 1. A sack slides off the ramp as shown with horizontal velocity of 12 meters per second. Sige. So if the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor and the range r where sacks begin to pile up. No? Sige. So, ang atong goal no, or atong objective no, for this problem is ma-determine si time and ang R, which or si range, no? Di ba akong na-mention earlier that R or range is just your horizontal distance, no? Or ang imuhang range sa imuhang trajectory, no? So, sa atong equation, that only refers to x. So, si x ato ang representation, ana. Okay? And also, di ba, si y, no, or sa atong equation, ang y is your vertical distance of your projectile motion, no, or from initial position to final position, mauna imuhang vertical distance, no. So, in this problem, point A is our initial position, and si point B ang ato ang final position, no. So, vertical distance is 6 meters. Therefore, ang 6 meter is muna siya si y, no, sa atong equation. So, given ang y. Also, okay, so wala na laing data, no, gihatag. So, kanilang siya. Sige. So, how do we solve for T? So, first, di ba gihatag ang velocity no at A. So meaning in our analysis no from point A to point B, VA or your velocity at point A will serve as your initial velocity. No, then your velocity at point B will serve as your final velocity, in which in this case wala siya ihatag. So VI or your initial velocity no, or your velocity at point A is equal to 12 meters per second. Sige. So, it was clearly stated sa problem nga horizontal velocity siya class, no? So, meaning, this only refers to our VI x, no? Or x component of our velocity. So, to prove that point, sige, let us consider this as our initial velocity lang, no? So, sige, VI. So, how do we determine VIX? Diba? To compute for VIX, naaman taan eh? VI cosine theta. Kumana ang ato ang computation or equation formula. So, this is VI cosine theta, in which ang VI is 12 meters or our initial velocity is 12 meters per second. Cosine, so angle of inclination. So, clearly, wala man siya naka-incline, no? Kay it was very clear, no? It is acting along horizontal no, or x component. So, meaning, 0 ang imuhang angle of inclination. So, cosine of 0 is, di ba, 1. So, meaning 12 times 1, you'll have 12 meters per second no, as your VIX. Okay? Now, for VIY, di ba, you have VI sine theta, in which VI nato is 12 meters and sine angle theta, atong angle of inclination, di ba, is 0. Then sine of 0, di ba, that is just equal to 0. So 12 times 0 would be 0. So this proves our point that wala tayo velocity no on y-axis. Okay? Sige. Now, to solve for t, unsa man nato ang need? Di ba naman tayo given na y is given, vi also is given, also ay yung viy is just equal to 0. So, using the second equation no, for y component of projectile motion, so y is equal to vi y t minus 1 half gt squared. No? Rasha class o. Next na equation. No? So, y is equal to vi sin theta times t minus 1 half gt squared. Where your viy is diba vi sin theta in which ato siyang na-solve. Nara siya class. Vi sin theta is just equal to 0. So, meaning, this is just equal to 0, no? So, or any number multiplied by 0, di ba mag-0 lang. Then 6, I mean si y, no? So, naasa to ang problem. Y refers to 6 meters. Minus 1 half. So, we are in SI unit of system of units, no? So, we will adapt or we will use gravity as 9.81 t squared. Okay, so this is a matter of quadratic equation class. So, i-transfer lang nato siya, no? We'll have, so 9.81 divided by 2. Pila man na siya? T squared equal to 6. Or plus 6 equal to 0. Okay? Therefore, T is equal to pila man. Kindly solve. 1.106. Okay. Wait ha, asa man ako siya isa lang. Diri na lang. Therefore, time is equal to 1.106 to, no? Tama. Seconds. So, na-solve na nato ang time, no? So, we now have time. So, meaning, the time duration of our projectile motion is 1.106 seconds. Sige. But we are not done yet, no, with our problem 1 since naman tayo other problem or another concern which is si x or ang range sa imuhang projectile motion. Sige. So, to find the range, di ba naman tayo equation of 4x component of your projectile motion where x is equal to vi cosine theta times t. Or, di ba this is only your vix times t. So, substituting the necessary data to our equation, you have x is equal to unknown. No? Siya di ato ang goal. And then, VI is 12 meters per second or VIX. Kani siya class. Then, time, na natay obtained value for time ng 1.106. Meaning, this is now equal to VI is 12 meters per second times time na ito ang 1.106. So, in this equation, isa na lang ang ato ang unknown variable. No? So, makompute na ito siya directly. Therefore, x no or range is equal to how much is 12 times 1.106. 13.272 meters, no? Okay? So, ano lang siya class, no? Question so far or clarification? So, ato lang i-verify, no? Sa tong reference. So, tama, no? X is 13.272 meters and time is 1.106 seconds. So, correct atong answers. Sige. So, wala question? Nasabtan ha? Sige, proceed to with sample problem number 2. We have here situation 2. Ako lang, mag-add lang ko daan og slides or blank spaces to accommodate our solution. Catapult is used to launch a ball such that it strikes the wall of the building at the maximum height of its trajectory. So if it takes 1.5 seconds to travel from A to B, determine the velocity, no, at which it was launched and the angle of release, and also compute for H. See, so we have three unknown variables no in our problem. So natay three objectives or three ato ang goal. Sige. So before we will solve this, let us just establish relationships no sa ato ang figure or sa ato ang given problem. So ato lang i-supply no ang given data, di ba? From A to B or from point A to point B, it took 1.5 seconds, no? So, given ang imuhang time of your trajectory. And, maura gyud siya ang given test, no? So, isa lang, time lang siya ang given. But, we have horizontal distance no, of your projectile motion, which is from initial position from point A to final position, which is si point B, na siya horizontal distance and it is equal to 18 feet. Meaning, sa atong equation, 18 is ang ato ang variable x. Okay? So, height. How do we determine h? So, how do we determine h? So, from this figure, h is just equal to ato na siyang elet. So, unsa gali na siya sa atong equation, di ba? This is just y. No? The vertical distance of your projectile motion. No? So, from initial position to final position, ang iyang vertical distance, that refers to y. So, ato siyang elet as y or i-denote ato siya as y. Meaning, h therefore is equal to y plus 3.5. Since na may initial height ang imuhang catapult, no? So, it has an initial height equal to 3.5 feet. So, naataan nga equation no, for h. So, meaning, to determine h no, or to compute for the value of h, we just need to find y. No? Si y lang ato ang pangitaon. Okay, so balikan nato na later. First, ato sang okay, so VA, initial velocity is unknown. Then your velocity at point B. So, unsa man, no? So, do we have data for VB? Wala siya gihatag, no? But, you have to take note that the ball strikes the wall no, of the building. So, meaning, at point B, your velocity is put to rest, no? Or it is put to stop, no? So, ni-stop ang imuhang projectile motion. Therefore, your velocity at point B is just equal to 0, no? So, VB is equal to 0. Okay? So, napabatay lain makita ang data. No? Wala naman siguro. Yes, so proceed na tanong sa ito ang solution. So, how do we find VA, no, or the initial velocity? So, in this given, natay x, no, data for x, wala tayo y, initial velocity is unknown, and also final velocity is unknown. But, from first equation, sa ito ang y component of projectile motion, di ba, Vy is equal to Viy, or Viy refers to Vi sine theta minus GT. No, tama na, muna siya class. So sorry no, I got distracted na ay nangutan na. Okay. So, di ba, mo na siya, ato ang first equation for y component, Vy is equal to Vi sine theta minus Gt. So, Vy, or in this case, no, our final velocity at point B, is it, di ba, it is equal to 0. So, ang iyang y and x component is just equal to 0 also. So, meaning, your final velocity on y component is equal to 0, equal to initial velocity na unknown, no? Sine theta. Angle theta is also unknown. Minus, okay. So, we're given length, no, is in terms of feet. Therefore, we will adapt US customary units, no, or system of units. So, minus 32.2 times t. So, okay, given ang time, no? At least natin given. Murag anong tanan. So, given ang time. Now, since 0 atong final velocity, so ma-express na to ato ang initial velocity na of y component equal to Vi sine theta equal to, so i-transfer lang na to siya sa left side sa itong equation, si 32.2 times 1.5, so how much is that? $48.3. Okay. So we have 48.3, no? And take note, diba, Vi sine theta, this only refers to VIY, no? Muna siya to ang VIY. Sige lang. Now, for x component, diba, given, so meaning, magamit na to ang second equation for x component of projectile motion, where x is equal to Vi cosine theta times t, in which time is given. Therefore, this is 18 all over 1.5 equal now to Vi cosine theta. Okay? Naka-follow? So, divide lang nato ang equation nato both side by time. So, x over t. So, x is given, which is 18 feet, and time is also given, which is 1.5 seconds. No? So, nata expression for Vi cosine theta, which is equal to how much? 12. Okay, na question? Na nag-raise a hand. Si Clint Malagamba?
Okay na sir, okay na sir. Sorry sir.
Okay, okay. Sige, proceed ta no. So, ato lang ako lang i-highlight no or emphasize that Vi cosine theta is, di ba, this is just our Vix, no? And this is our Viy also. So, sige lang. Now, so, you have to take note that your initial velocity, no, or your Vi should be equal to your Vi here. Kay they are just the same man class, no? They are equal in magnitude. They should be equal in magnitude. So, meaning, pwede na to na siyang gamiton ng equation. So, i-express na to ang Vi equal to 12 over cosine theta. No, divide lang na to ang equation by cosine theta. So, you'll have this equation. No? So, meaning, na-express na nato si Vi in terms of its angle of inclination, no? I-substitute namin na to na siya sa ang isa pa ka-equation, no? Kani siya si Vi sin theta is equal to 48.3. So, meaning, the resulting equation now would be, sa to, 12 over cosine theta times sin theta is equal to 48.3. Diba? So, asap na siya gikan. Nara-class of Vi sin theta. Ako na lang isulat para maka-follow. 48.3. Diba? Muna siya. Then, atong i-express ang Vi in terms of 12 over cosine theta. So, ato din siyang i-substitute, no? Vi as 12 over cosine theta. So, we'll have this equation. And again, naana po si sine theta over cosine theta, no? So, we can further simplify this equation into 12 tangent theta. since from trigonometric function or trigonometric identities rather, no, your tangent theta is just equal to sine theta divided by cosine theta, di ba? So 12 tangent theta is equal to 48.3. So tangent theta therefore is 48.3 divided by 12. So to determine or to compute angle of inclination, no, so inverse function of tangent of 48.3 divided by 12. So how much is our angle of inclination? So 76.048 degrees. 76.048 degrees. Okay? So we have solved angle theta, no? So nakuha na nato ang isa ka question sa to ang problem, which is the angle of release. Okay? Sige. So to determine the initial velocity, si VI, di ba naataan ng equation no, nga VI is equal to 12 over cosine theta. And in that equation, ang ato alang problem is si angle theta. But since na-compute naman nato ang angle theta, so ma-compute na po nato ang initial velocity, which is 12 over cosine 76.048 degrees. No? So how much is VI? 49.777. Sige. Feet per seconds. Okay? So, na-compute na nato ang second question, no? Or the first question, by the way, sa ato ang problem. So, the velocity at which it was launched, no? So, basta matingala mo nga, VA ang gipangita, no? Then, ang atong answer is naka-VI. So, in this manner, or in this analysis, VA will just be our initial velocity, di ba? So, initial point nato is si point A. Therefore, our velocity at point A is our initial velocity. Okay? Nato lang siyang i-denote as VA. VI rather, no? Now, di ba ako itong i-highlight earlier that kaning VI sine theta and our VI cosine theta is just our x and y component of our initial velocity, or si VI and si VIY and si VIX lang, no? And if you recall from our discussion earlier on general curvilinear motion, to compute for the magnitude of the velocity, we'll just have to take the square root of Vx squared plus Vy squared, no? Or ato lang i-square din square root of sa ilahang components, no? Sa imong velocity. So therefore, since we have asa to, VIY and VIX, no, equal to 48.3 and 12, we can actually compute directly, no, for VI. VI is just equal to square root of VIX squared plus VIY squared. Therefore, VI is equal to square root of pila to siya? 48.3. No, VIX is 12. 12 squared and VIY is 48.3 squared. Therefore, VI is how much? No, it should be equal to 49.770 plus kay para valid ang ato ang solution, no? So this is just your murag checking ba, no? So this is another possible solution, no, for this problem. So you have plenty of options on how to solve this problem. So parehas ra na sila og value dapat plus. Okay? Now, and also, di ba na-mention na ako nga, your VI here should be equal to your VI here also, no? So, atong gisolve ang VI using this equation, no? Nga 12 over cosine theta. So, dapat, ang imo pong makuha nga VI no in this equation, it should also be equal to 49.77p. Okay? Para valid ang ato ang computation. So, VI is equal to 48.3 divided by sine theta. So, that should also be equal to 49.770. Okay? So, nakay murag 3 ka-checking, no? Or 2 checking rather. So, anyway, regardless of kung sa inyo ang gamiton, so it is correct. Okay? Now, unsa pa bay, okay, height na lang atong kulang, no? Ang height na lang I mean, dili atong height, but rather, height sa imuhang final position, no? Point P from the ground. Okay? So, to compute for height, di ba, nata equation that height is equal to y plus 3.5 feet. So, y ang ato ang problema. So, how do we determine y? Di ba we have the second equation of y component of your projectile motion equal to vi sine theta minus 1/2 gt squared. Given ang time, constant ang gravity, so si vi sine theta ang ato ang problem ani, in which in this part sa atong solution dili na to siya problem since nakuha naman nato ang vi as well as ang imuhang angle theta. So you can just directly substitute no those values to your equation para ma-solve na to ang y. But ako lang gamiton nga relationship kani siya class oh. Diba VI sin theta is equal to 48.3 and it says here that VI sin theta. So meaning ako na lang siyang gamiton. So 48.3 minus 32.2 ato ang gravity no times time na 1.5 squared. Okay? Sorry, narito siya T, very class oh. I-insert na lang ako. Minus 1/2. So how much is y? $36.225. Sige. So you have here y equal to 36.225 feet, no? But this is not our final answer since dili man ang height sa imong trajectory ang gipangita or trajectory ang gipangita, but rather the height of your final position from the ground. So plus 3.5. So height therefore is 36.225 plus 3.5, that is 39.5 or 0.2, so 0.725 feet. No? Okay. Questions or clarifications? Asa nga part naglibog? Nasabtan na class? So, I'm assuming na nasabtan ha. Sir, nga na gani 32.2 ang gigamit ng gravity. Okay. So, balik ka sa problem, no? Sa problem, wala siya gi-state, no, kung, or wala tayo idea kung unsa nga system of units ang atong gamiton kay seconds naman ang gihatag or uptime naman ang given. But, observe that sa ato ang given figure, ang imuhang length is in terms of feet. No? So, meaning, we're gonna use US or English system no nga units para compatible ang ato ang given data no to our solution no. So ana lang siya. And di ba constant pa nato ang gravity? If SI you have 9.81 meters per second squared, and if nata sa English system, you have 32.2 feet per second squared. Other concerns? Okay, so I hope nasabtan ha. So, wait lang, break sa taong mga 5 minutes. Inom sa akong tubig class. Okay, so continue na tayo. So let's have our last sample problem for this session. We have here the muzzle velocity of a projectile is 1,500 feet per second and the distance of the target is 10 miles. Sige, so what must be the angle of inclination of the gun? Sige, ato lang i-drawing ato ang free body diagram, no? So, let's say for example, na atay ako lang i-represent no as this one. Muning gun. So, pusil ni siya ha. And na siya initial velocity equal to 1,500 500 feet per seconds. Okay. Sige. So, ato lang siya i-consider again as a particle, no? At the concentrated at the center of gravity. So, let's say, for example, na adre yung center of gravity. And that would be our particle, no? And then, 10 miles away, no, from our muzzle or from the gun, you have your target, no? Sige. So at distance 10 meters at 10 miles tayo, no, rather. Okay, kanina aning target, no? Sige, atong imuon tao siya. So stick lang sa atong tao for today. Brutal kay ba tao gid ang himong target. And then, di ba this is 10 miles daw, ang ihang distance. So what must be the angle of inclination, no, with respect to horizontal ang imuhang gun, no? So what must be the angle of inclination of the gun to hit the target? So let's say one ang projectile, no? So bullseye din siya. Sige. So wala tayo time given, no? So wala gihatag nga time. So ang data nga atong gihatag lang sa ato is initial velocity and x, no? Since 10 miles will serve as x, no, sa ato ang equations. But before that, since velocity is given by 1,500 feet per second, so meaning we are in English system gihapon ta, no? So we will be using 32.2 feet per second squared nga value of gravity. Okay? And since naka feet per seconds pa ni sila, so it is much convenient if si miles, no, ang atong i-convert into feet. So how much is 10 miles in feet? So diba that is just in 1 mile you have 5280 or 5,880 feet. No? So, cancel na siya. Therefore, x is, so 10 times 5280 is 52,800. No? Since 10 lang ang ihang multiplier, so madugangan na siya og 0. Okay? Okay, paano siya x? Na. So, na tayo data for x, initial velocity, and maura ang yatag sa problem. Sige, so how do we solve this? First, notice that your particle, no? Let's say, for example, from this point, si point A, ato siyang i-denote as point A, no? And then si point B, they are just co-linear, no, with each other, no? So they are on the same elevation, which means that our value for y is just equal to 0, no? Y is just equal to 0. Ano man? Because again, no, by definition, your y, no, in our equation should be the vertical distance of your projectile motion, no, relating to its final position to its initial position, no, since to ang initial position and to ang final position are just collinear, so wala siya vertical distance, which means y in our equation is equal to 0. Okay? And then gamitin na to ang derived equation. Diba you have this equation, y is equal to x tangent theta minus gx squared. This is not 9, ha, that is gravity. Gx squared all over 2i, 2vi squared cosine squared theta, no? So y, we have data for y, no? Now ato siyang establish as equal to 0. given ang x, unknown ang angle theta, which is, by the way, mao atong objective no for this problem. Gravity is constant, x is given, initial velocity is given. Therefore, in this equation, isa lang ato ang unknown variable, which means that we can directly compute for the unknown variable. So, ato lang substitute no ang ato ang data to the equation. No? So, supplying the data to our equation, you have y is equal to 0, x is 52,800, tangent theta. So, unknown si theta minus, dire na lang ako siya i-write sa ubos class, no? Gravity na 32.2, x is 52,800 squared all over 2 VI na to, no? Or initial velocity is 1,500 squared cosine squared theta, in which unknown. Therefore, we can directly compute for the angle theta. Na. So, how much is angle theta, class? Finally, compute. Okay, so base nag-worry mo ani nga part class mo, no? Ano siya? Sa ano pag-input sa inyong calculator? Kaya, di ba? Kinana mong kita, murag ato yung kopyahon ang form niya ba, no? So, take note that from trigonometry, geometry, or sa on basic algebra, no? That cosine squared x is just equal to cosine x squared, no? So, ang imong i-input sa inyong calculator, kaya dili man ninyo siya ma-obtain nga form, no? So, kani siya. So, cosine, maana man na si calculator, no? So, x squared. Then, shift solve, obtain mo si angle theta. So, how much is angle theta? So, we have here, angle theta is equal to 24.54 degrees. Okay. So, muna rin na siya to ang final answer, no? For situation number 3, since angle of inclination lang man ang gipangita. So, questions so far or clarifications? Okay, wala ha. So, next week would be your midterm examination, and ang atong schedule is on April 7, 2022. So, that is Thursday next week, 10 a.m. to 12 p.m. No? So, 2 hours of exam, midterm exam. So before ta mo i-dismiss, let's just check your attendance. So say present if you are here sa meet. Today is, it's karon 29. Aberin Monique, Abrenica Hannah Grace,
Present,
Asibar
Chair.
Maria Christine,